Okay, next we have a refrigerator and second law of thermodynamics. Before discussing the refrigerator, I will discuss a little bit about heat engine. Like we have a heat engine in which we have two temperature reservoir. One is low temperature reservoir, its temperature is TL, and the other one is high temperature reservoir and its temperature is TL. And here we have the heat engine. Now in heat engine we give heat to this engine from a high temperature reservoir QH. It converts this energy heat to work done, and also a part of that heat is lost to the low temperature reservoir. This is the working principle of heat engine. Heat engine. Now a refrigerator is basically a heat engine. A refrigerator is a heat engine, but it work in a reverse direction. Like it's a heat engine, okay? Its working principle is almost the same. We have two temperature reservoir. One is low temperature reservoir, its temperature is TL, and one is high temperature reservoir and its temperature is TH. And we have this engine. And refrigerator, heat is given by the low temperature reservoir KFL and is converted into high temperature reservoir HQH by doing so through the expense of some work which is given here. So if we look at here, everything is reversed now. Like the arrow sign here shows the output, and here this shows the input. Here this shows the output and this shows the input. So they are reversed now. Now in this case, this KH comes from two things. First we give heat, KL, and this heat is moved to this high temperature reservoir by some external work W. Or we can write the absolute value, which is like this. From this we get the KL, the heat given by the low temperature reservoir is equal to QH, heat gained by the high temperature reservoir, minus, or we can write it as like this. The work done, I need the work done. Work done is equal to QH, the heat gained by the high temperature reservoir, minus KL, the heat given by the low temperature reservoir. Now an ideal refrigerator is that kind of refrigerator in which there is no work done by some external source, by the engine, but heat is directly transferred from low temperature reservoir to high temperature reservoir. So this part will be equal to 0. But in reality this is not possible, because if we move heat from one point to another point, or if we transfer heat from one point to another point, then we need some work done, according to second law of thermodynamics. So this is the working principle of heat engine, and the efficiency of a refrigerator is measured by an index. It is measured by an index, okay, which is called the coefficient of performance. The coefficient of performance, K, and is defined as, we define it as like this. K is equal to heat supplied by the low temperature reservoir and the work done. Now heat supplied by the low temperature reservoir divided by work done has this value, put it here, which is QH minus QL. Or in terms of temperature, the above equation can be written as K is equal to QL is replaced by TL divided by QH is replaced by TH minus QL by TL. But we will take the absolute value TH. This is TH, okay. For ideal refrigerator, like a refrigerator in which heat given by the low temperature reservoir is converted into high temperature reservoir totally, then for ideal refrigerator, the work done must be 0. And we have, if work done is 0, then QH minus QL is equal to 0. Then QH is equal to QH, heat given by the taking by the high temperature reservoir, will be equal to the heat given by the low temperature reservoir. This is for ideal refrigerator. Now the coefficient of performance of such a refrigerator will be infinite, but like in that case the coefficient will be this K. If this is the case, then K will be equals to infinity, because TL over 0 we get infinity. But real refrigerator engine can't do this, because we need some output to convert that heat, this heat from low temperature reservoir to high temperature reservoir. We need work done. So it means that the Clausius formulated in another statement for second law of thermodynamics, which says that, what is the statement about the second law of thermodynamics? Clausius statement is, it is not possible for any refrigerator working cyclically, like the refrigerator is working cyclically, yes, to convert the entire heat energy, absorbed heat energy, to its high temperature reservoir. Without any external working done by the motor. Without any external work done. By the motor. What it means? It tells us that for any refrigerator it is not possible to convert, this is low temperature reservoir and this is high temperature reservoir. Its temperature is TH, its temperature is TL. It tells us that it is not possible to convert the entire energy given by this low temperature reservoir to higher temperature reservoir, TQL, QH. This is not possible without any external work done by the motor. If there is no work done by the motor, then heat cannot be converted from a low temperature reservoir to high temperature reservoir. This is the Clausius statement of second law of thermodynamics about refrigerator. This is not possible according to this statement. So this is another definition of second law of thermodynamics. So this is all about refrigerator. In the next video we will move to the Carnot cycle. Thank you.